Alright, starting this video, this is going to be for class lecture for Integrated Math 3 on September 4th, Friday, September 4th. Enjoy. Alright, so today we've been talking about polynomials and how to graph them, and we started to talk about dividing a little bit. And so today I'm going to go through the division algorithm for long dividing polynomials. So you might hear this referred to as just the long division algorithm or just long division. But it is a useful skill to have. So first, before I do it for actual polynomials, I'm going to kind of show you the equivalent way that it works equivalently to if you are dividing numbers. So first I'm going to do something you should be very familiar with. Let's make my marker a little bit darker here. So say we're dividing, and this may be a little bit less thick. Say we're dividing 423 divided by 16. Okay, so when you're learn the division algorithm in 4th or 5th grade, you learned how to do this. So when you're doing the division algorithm, depending on how many decimal places you need, you might want to add some decimal places in case it turns out not to go into it evenly, depending on what your needs are. So first what you do is you look at the number 16, and then first you would look and say, okay, does this go into 4? No, it does not. So then you go over to the next digit, and so now you have a 42 here. And so 16 does go into 42, and so then you need to figure out, okay, how many times does it go into 42? So if you think about it, it's going to be 2. 16 times 2 is 32. Okay, so then what you do in the division algorithm, you're going to multiply. 16 times 2 is 32. You write that number down here, and then you subtract it. Okay, so then you subtract it. So we're going to have basically a 10 left over. And then the next step is, of course, you bring down the 3, and now you kind of do the process all over again. And this just keeps repeating, of course. One thing I'll mention here is that, of course, this is representing the fact that the number 16 goes into 423 not 2 times, but actually 20 times, because this is in the tens digit. And so what we've really done is we've done 16 times 20, which is going to be 320 actually, and then we subtracted that 320. Now there's 103 left over. Okay, so we've already taken out 20 times 16, so we need to figure out how many more 16s go into what's left over. Okay, and so basically that idea that you just keep taking bigger chunks out of the number until you get to either it's going to go into it perfectly, or you're going to have a chunk left that's so small that 16 doesn't go into it at all. Okay, so that's the basic idea, and the basic idea, of course, continues and applies to polynomial long division. But let's just finish this off. So now we have 103. How many times does 16 go into 103? Well, 16 times 5 is going to be 80. I believe it should go in one more time, so it'll probably be 6 here. So now we do 16 times 6. So what we can do is we can do 10 times 6 is going to be 60, and then 6 times 6 is 36. So if we add the 60 plus the 36, we'll get 96. Okay, and this represents 16 going into this number 6 times, because this is in the ones place, of course. And so now we multiply 16 times 6 is 96, and then so we subtract, and so we have 7 left over. And of course, if you want this, since we have a remainder here, this is the ones place. Depending on which you need here, you could say remainder 7, 26 remainder 7. That's an option. You could say 27 and 7 over 16. Okay, so in other words, you could write it like this: 423 divided by 16 equals 26 and 7/16. You could write it like that. Or of course, if you wanted a decimal form, you could keep going. What you do is you'd bring down the 0. And so now you're asking yourself, okay, how many times does 16 go into 70? Okay, and then of course, if I was going to do that, then I would not want this fraction here. 16 would go into 70 probably 4 times. 64, subtract 6, bring down your next 0. And you can keep going for as long as you need to keep going. Alright, so hopefully you get the idea. That's how long division works. It's just an algorithm figuring out how many times a number divides into another number. So it works very similarly for polynomials. The process is very similar. So instead of worrying about place value, you're actually worrying about the different degrees, or you're looking at another way of saying that is what power of x. So whereas when you're doing long division, you want to line everything up according to place value. So you want all the hundreds to line up, all the tens to line up, all the ones places to line up. When you're doing polynomial long division, you want all the x to the first powers to line up, all the x to the second powers to line up. And the reason is because when you're adding like terms, those are the ones you're going to be adding together, or perhaps subtracting, because subtracting is part of the process. So I'm going to do a pretty basic example here to kind of show you how it works. And this is a process that takes a little bit of practice, or maybe for some of you quite a bit of practice. So again, it isn't really like, the whole point isn't just, oh, I don't get this, I'm just gonna give up, I'm not gonna be able to learn it. Math, just like anything else, it takes a little bit of practice. And so it's a process of learning how to do something. And so the more you practice it, the better you will get at it. And I promise that all of you can do this. All right. So when you are dividing by a binomial, in the videos you should have watched yesterday, you learned how to divide by just something that was, if you're dividing by x, or maybe by 3 times x, you learned about that. But if there's two terms here, there's, you could try to factor it out, obviously, and you'll watch videos in which Sal Khan will do that. I'm going to show you how the division algorithm works, and so there is other ways of doing this problem, but you will need to learn the division algorithm for later, because you'll have more complicated problems. Okay, so when you're doing this, you're going to look at your biggest term here and your biggest term here. Okay, you're not really going to ever worry about this one or any of the terms back here until later. So what you're going to do is you're going to look, okay, how many times does this x go into this x squared? Okay, in other words, x times what equals x squared? Okay, well, it's going to be x. X times x is x squared. So just like in the division algorithm for numbers, that number you're going to multiply, you're going to put it up here, and you're going to line it up in the appropriate column for degree. Also, all the x to the first you want lined up vertically. So now what do? Now we multiply, just like the division algorithm. So we do have to multiply by both terms of this x plus 1. So we have to do x times x is x squared. And again, we're going to keep everything lined up. So that x squared I'm going to put in the x squared column here. And then I'm going to do x times 1. And that's going to be plus x or plus 1x. Okay. And so the next step is to subtract. Okay, now there's different ways of doing this, but you really need to be careful here, because this is one of the most common errors that students will make, is they will forget that they need to subtract here. Okay, because sometimes you will end up with a negative sign that's already here, and so if you're subtracting a negative, that really means you should be adding. Okay, in this case they're both positive, so what I usually do is I just change my signs and I'll circle it. So I know that that's the sign that I need to go by. So that would mean if this was a negative 1x, I would need to change it to actually a positive. And I would circle that so I know that I'm actually adding here. Okay, but I need to subtract, so I got x squared minus x squared, and that's 0. Okay, if you're doing this right, you should get zeros every time up until you get to the point where you have possibly a remainder. The remainder may be 0. You may have no remainder, a remainder of 0. You may have like a number left over. But if you end up with something else here, you probably messed up. Okay, you probably multiplied wrong, or you have the wrong number up here. Okay, but let's continue on. Let's subtract. So we have 8x minus 1x. This is going to be a positive 7x. Okay, so next, just like long division, we're going to bring this down, this 7 down, so this plus 7. And so now we're just going to do the process again. Okay, so now again I'm looking at the first term here, but now I'm looking at this first term. So x times what is going to be 7x? Or in other words, how many times does x go into 7x? Well, it's just going to be multiplying by 7. Okay, and so now the division algorithm is we multiply 7 times x, 7 times 1. Okay, and again we subtract. So that means I change my signs because adding the negative is the same as subtracting. So adding the opposite sign. And so now we subtract. So 7 minus 7, this is going to be 0x. 7 minus, I did something wrong here. 7 times 1 should be 7. 7 times 1 should be 7. So this change, we are subtracting, so we change the sign to a minus 7. And so we get a plus 0. So this one went into it evenly. Okay, so the theory behind this, the reason this works is very similar to the division algorithm. So basically, if you multiply x plus 1 times x, then you get this. You get x squared plus x. And so if you subtract that out, what's left over, we still have to see, okay, with what's left over, can we get x plus 1 to go into it even more? Okay, and so basically you go like term by term, and so you're first starting with the x term, then 7, and so your degrees will get smaller and smaller as you go down. But what does this mean? This means, because we got 0 as a remainder, so this means that it goes into it evenly. So you could think of this a couple different ways. So you can think of this problem, the problem that I originally did was x squared plus 8x plus 7 divided by x plus 1, and then we did the algorithm and we found out that if we divide it out, it's going to be x plus 7. Okay, so if you imagine here for a second, you'll figure out that we could have factored this, because if I wrote it like this, and then imagine for a second I do a little bit of algebra. Imagine I multiply both sides by an x plus 1, and of course you would imagine there's parentheses around this, because if you're multiplying the whole right side by x plus 1 in parentheses, you need to use parentheses around the x plus 7. What would happen is these would cancel out, and so I'd be left with this. X squared plus 8x plus 7 is equal to x plus 7 times, and I ran out of room here, but x plus 1. And so this is really just confirming how this factors for you. Okay, because remember we learned how to, or not in this class necessarily, but you've learned how to factor trinomials, and so you should realize that this trinomial would factor to x plus 7 times x plus 1, because 7 times 1 is 7, and 7 plus 1 is going to be 8, which is the term right there. Okay, and so, and again, the definition of division, if I'm dividing by x plus 1, I'm really asking myself, and this, I didn't do a great job making this point, but I'm really asking myself, if I'm doing x squared plus 8x plus 7 divided by x plus 1, what that what I'm really asking is x plus 1 times what equals x squared plus 8x plus 7. Okay, and then of course from right here we've seen that what this should be is the x plus 7.